All right, here we go. Section 7.7, take 3. This is my third attempt, third recording. I keep losing my recordings before uploading them to YouTube. Not a big deal. Section 7.7. Last section of chapter 7. It was write and apply exponential and power functions, but we decided as teachers that we would eliminate the power functions. We learned about power functions chapter 6, but this should be enough just for us. So I have 2 examples, and that's it for you. So the first one, let me scroll this back. That was from the last take. So let's start up here. The example is write an exponential function in this form, right? This is y is equal to a times b raised to the power x. Again, exponential function because exponent x is, the variable x is an exponent. We're going through 2 points. So again, if I just said, hey, 2 points, you could make a line from that as well. But because we're told to do an exponential function, that should be enough. So we are going to plug in the points into the equation. So when x is 1, y is 10. And when x is 4, y is 80. And we are, our goal here is to solve for either a or b. I would recommend solving for b first, and I would recommend solving kind of the simpler equation, and the power 1 is simpler than power 4. So solve that equation for a. And so the book does that as well. You take the first equation and b to the power 1 is just b, divide by b, and you get 10 divided by b. Substitute that into the second equation. You can see 80 is equal to 10 over b times b to the 4th. The b's would cancel down to b to the 3rd, right? b to the 4th divided by b is b to the 3rd. I would then divide by 10 both sides. I've got 8 is equal to b to the 3rd. And here we would take the 3rd root of both sides, or raise to the power 1/3, right? Nice exponent practice. And b is equal to 2. How would we solve for a? Right here. Look at this equation. It's waiting for, waiting for it. And 10 divided by 2 is 5. So a is 5. And then you would write it, and here's your final answer, right? You've got an exponential function. It would be great if you would try one yourself now, right? So exact same procedure. The points are different. So substitute 1 in for x, 8 in for y. That's your first equation. Substitute 2 in for x, 38 in for y. That's your second equation. And then make a strategy for solving for both a and b. Hit pause, and when you're ready, I'll show you my solution. And there it is. So the final answer should be 2 times 4 raised to the power x. Again, plug both points into 2 different equations. I took the easier equation, which b to the power 1 I saw was thought was easier, and I solved for a, substituted that into the second equation. The b squared and the b cancels down to b. I don't even have to take a root now, right? 32 divided by 8 is 4. Substitute back into the a equation. 8 divided by 4 is 2, and I've got it. Nice, well done. So here we go. This is some raw data, let's say, right? So this is data from savings, and you've got, 8 years or your initial, and 7 years later, you've grown your $210 to $822. And we would like to see if this is an exponential by plotting the points, if we see that exponential growth curve, and then we'd like to come up with an equation, a model. So I think the handout I gave you had quite a bit of steps to do that, but I'd really would prefer that you learn how to do it on the graphing calculator, so let's switch to that. So in your graphing calculator, you would enter the data. Again, remember we go to Stat, hit Edit, and then put the data in. I've already done the data. I've put it in. List 1 has the times, 0 to 7 years, and list 2 has the values of your money. To see if it is indeed, and you can kind of see already the graph down here, but how do we get there? Second y equal to is your stat plot. And for stat plot, I turn the stat plot 1 on. I pick scatter. By default, it does list 1, list 2. And again, zoom stat. Zoom number 9 is a great button to get the data right in the window. And that definitely does look exponential, right? Has a nice little growth. Could be, you could look at it as well and see, oh, it's a little quadratic. And you could force a line through it. But we are going to do a exponential regression. So we go back to the stat button, slide over to calculate, and then we have to scroll down. So we passed our linear regression, quad regression, cubic, quartic, second form of linear. There's LN, natural log regression, powerful. But here we are, exponential regression, 0. So your calculator should do list 1, list 2 by default. You just enter, 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 and then here we go, calculate. And there's your equation. So A is 210 if you wanted to round aggressively, or 209.955. And your B, your base term, is 1.215. And you could take those numbers and type them into y equal to. So I did that already. And if I turn on this, and I can see the graph, and you'll see what an amazing fit, right? It's just, the equation is a perfect fit for the data. The graph's going through all the data points. And if you remember this 209 and 1.25, let's go back to our slideshow. And if I scroll down, I can see that is the answer that the book also came up with. Or pretty close, right? A little bit off, but not bad. So I'd encourage you on Monday, when I see you, we'll have a few of these and we'll get in the calculator and do it that way. All right, I'll see you Monday. Thanks so much.